Hey, how's it going, class? Mr. Farrell here with our thermometer stirring experiment, okay? So for the thermometer stirring experiment, we're just gonna need a few materials. So first we wanna have ourselves a beaker, maybe 500 milliliters, or just a large container, okay, that we'll be able to pour all of our water into. All right, we're gonna want about 400 milliliters of water. We want that water to be cold, okay? So you want it to be in your refrigerator maybe for a whole day, or you can take some water and put it in the freezer for about 2 hours just to get it really cold before we use it in our experiment. Okay, we don't want it to be frozen, but we do want it to be cold. We're also going to need a stirring device. Here I have a spoon, plastic spoon, and we're going to want our thermometer, okay? Now, for this experiment, we are calculating the heat needed to change the temperature of water, okay? So we are going to be stirring this water and trying to find out how the temperature changes, okay? We're going to be doing this for about 20 minutes, stirring the water, measuring the temperature, stirring the water, measuring the temperature, every 5 minutes until we get to 20 minutes, all right? So what we want to do first is go ahead and write our introduction to our lab. So remember, your introduction should be a relevant title. You should also write a summary of what you're doing in the lab, and you should include a hypothesis, okay? So a relevant title should be something dealing with thermometers, water, or stirring. The summary of the lab you can actually get from your procedure. So what are you doing in this lab? What are you trying to measure in this lab? So the procedure and the overview of the lab can help with that. And then for your hypothesis, you just want to think about what do you think you're going to find in this lab? What do you think you're going to find about the heat added to the water or the temperature of the water? How do you think it's going to change? Your hypothesis should deal something with that, all right? So after you take a minute to pause this video and write your introduction section, all right, also go ahead and write your method section. So your method section is going to be copied directly from the procedure of this lab. So you can write down the steps that are in this lab, really verbatim, or exactly as they're written, just copy and paste them into your lab write-up. All right, so after you do that, you should be good to start the video again, and we'll continue going. And I'll just start from that point. So we have our introduction done, our method section done, and now it's for the data analysis. So for the data analysis, we have to first collect our data. All right, so I'm gonna go ahead and I'm gonna pretend to stir this water for 5-minute increments up until a full 20 minutes. And we're just gonna walk through how you should do this lab. Okay, so I have my extremely cold water that I just put inside of my beaker, all right? Our data table that you can see here starts off at 0 minutes. So at 0 minutes, that means as soon as the water is put inside of our beaker, we wanna know what the temperature of the water is, according to column 2, okay? So I'm gonna take my thermostat, or my thermometer, go ahead, put it inside of the water, wait a little bit for it to steady, and then I'm going to measure that temperature. So let's say the temperature for the thermometer at 0 minutes when we first put the water in is 2 degrees Celsius. And we want to make sure to measure our temperature in degrees Celsius. Okay, so I would write that down in my table. As you notice, the temperature change column is blacked out for this first box. And that is because our temperature didn't change at all when we first put the water inside of our beaker. All right, so we're going to go ahead. For the next 5 minutes, we're going to stir, okay? You can stir fast, you can stir slow, you can experiment with them every 5 minutes. Maybe you stir fast for the first 5 minutes and stir slow for the second 5 minutes and see what happens. All right, but we're going to keep stirring this for 5 minutes, okay? Let's say we did that. Now we're going to go ahead and measure the temperature again with our thermometer. All right, once it steadies, we're going to go ahead and record that. So let's say our second temperature was 4 degrees Celsius. So we would write that in our next box. Now, when you look next to it, it says temperature change, and this box is open. So here you want to write what was the change in temperature from 0 minutes to 5 minutes. Now for us, at 0 minutes, our temperature was 2 degrees Celsius. At 5 minutes, it was 4 degrees Celsius. So we would write a change in temperature of 2. all right, 2 degrees Celsius. All right, now let's go ahead and keep stirring for another 5 minutes. Okay, so let's say we did that for 5 minutes. We're gonna go ahead, use our thermometer again to measure the temperature. All right, and once it steadies, let's say my temperature measures 4 degrees Celsius again. Okay, so for 10 minutes, I'm gonna write 4 degrees Celsius as the temperature of the water. Now when I look over into my box that says temperature change, from 5 minutes to 10 minutes, my temperature was 4 degrees Celsius, and then it stayed 4 degrees Celsius. So for my temperature change, I'm gonna write 0, okay? Now we're gonna go ahead, keep stirring, okay? Do that. 15 minutes, right? We would stop, measure our temperature again, okay? Record that in the table. And then for our last 5 minutes, we're stirring again, okay? Now we reach 20 minutes. So we stop stirring, go ahead, measure the temperature, and record that. All right. Now again, each time you record your temperature, you want to look at the change in temperature from the previous time and record that in your temperature change column. Okay. Now that we finished that, let's go to the board and take a look at our data and really begin to analyze it and work through the rest of this lab. All right, so we are back looking at some of the data we recorded in this experiment. All right, so I've got my data tables here. Okay, we're not gonna focus on data table 2 first. Let's go ahead and look at data table 1. All right, make sure to always label your data tables when you're doing your experiment write-up. Okay, so for data table 1, in the far column, you can see the time. Okay, so these are all the times: 0 minutes, 5 minutes, 10 minutes, 15, and 20 minutes. Okay, over in column 2, you'll see the temperature of the water that we recorded. So for the purposes of this example, I said we recorded 2 degrees Celsius first, 4 degrees Celsius at 5 minutes. It's remained 4 degrees Celsius at 10 minutes. Then we measured 7 degrees Celsius at 15 minutes and 9 degrees Celsius at 20 minutes. Okay, now in this far column, this is the temperature change column. So again, our first box is blocked out because the temperature did not change when we first put the water in the beaker. After measuring 5 minutes, we saw a change in temperature of 2 degrees Celsius. From 5 to 10 minutes, there was no change in temperature. From 10 to 15 minutes, we increased the temperature of the water by 3 degrees Celsius. And then from 15 to 20 minutes, we increased the temperature of the water by 2 degrees Celsius. So now we have the first table completely written out, and we are now going to begin to get into the meat of the lab. So again, what we're trying to figure out is how much heat energy was added to the water during each temperature change, okay? So now we're going to go to our table 2, all right? And if you can see this in table 2, over here we just have our changes in temperature. So the changes in temperature that we wrote in table 1, we're just gonna take those and write them in this column in table 2. And then over in the next column, we have heat energy transfer. So we're going to measure this in joules because energy is measured in joules. But in that table, we are going to write all of our calculations for the heat energy that was transferred into the water as it changed temperature. Okay? So in order to do that, we are going to need to use our equation for calculating heat energy. Okay? So let's go ahead and move this camera up, and we are going to look at the equation here on the board, okay? So our equation for calculating heat energy is mass, the mass of the object, times its change in temperature, multiplied by its specific heat capacity. And that's gonna give us the thermal energy or the heat energy, which is Q. Now again, briefly talking about the specific heat capacity, that is how much energy it takes to change the temperature of 1 kilogram of a substance by 1 degree Celsius or 1 Kelvin. Okay, so to change the temperature by 1 degree Celsius, how much energy does that take? Okay, this quantity varies for different number or different materials, right? Because some materials are easier to heat up than others. All right, so we're going to have a specific specific heat capacity number as we figure out how much energy is needed to change the temperature of water. All right, so we're going to see that here. When we look at our first example calculation, we have the mass of our water. Now this you can actually find in the materials section. It says we're using 400 milliliters of water, which has a mass of 0.4 kilograms. So our mass came straight from that. Over here we have the change in temperature. Now, as you can see, we're going to plug in the change in temperature that we calculated. So for our first change in temperature, we calculated a change of 2 degrees Celsius. So we're going to plug that in here. And here we have the specific heat capacity of water, which is 4,186 joules per kilogram times degrees Celsius. All right. Again, you might see this sometimes as joules per kilogram Kelvin, which is true. But here our temperature change is measured in Celsius, so we're going to use Celsius over here as well. Okay. Now again, this is saying it takes 4,186 joules of energy to heat up 1 kilogram of water by 1 degree Celsius. Okay. And of course, that's going to give us the heat energy that was used, that we added to the water by stirring it. Okay. All right. So when we go ahead and multiply these numbers straight across, we're going to calculate the number 3,348.8. Now our unit is going to be joules because this kilograms being in the numerator cancels out with this kilogram in the denominator. And this degree Celsius in the numerator cancels out this degree Celsius in the denominator. So we are left with joules as our unit. And of course, joules is the unit we would like to have because it's the unit of energy. Okay? So 3,348.8 joules was added to our water during the first 5 minutes of stirring. We're going to go ahead and write that in our table under heat energy transfer in our first box. Okay? Now, we're not going to continue to calculate the rest of the numbers, but what you would do is you go ahead, rewrite this equation because the mass of the water is still the same. The specific heat capacity of the water is still the same. The only thing changing is the change in temperature. So you would continue to change whatever your new change in temperature is, you would plug that in here and calculate this answer again. Now, our next change in temperature was 0 degrees Celsius. So here we would plug in 0 and multiply across. And so we get 0.4 times 0, which equals 0. And then we multiply that by 4,186, and that would still be 0. Okay, so actually our next line in this table would be 0 joules. So during that next change of 5 minutes, we actually did not measure any energy being added to the water. Okay, so with that said, we now have, after you take the time to finish calculating your numbers, you will now have a complete table 1 and table 2. So now we're going to talk through what do you do once you have a complete table 1 and table 2. So for your lab, your experiment write-up purposes, your introduction is now done, and so is your method section. Your tables for your data analysis section are done now. And so the last thing you have to do to finish out your data analysis section is write descriptive paragraphs for each table. So your descriptive paragraph should include a summary of what the table is about and a trend that you see among 2 columns of the table. So for example, we want to talk about, we want to share that this table is talking about the time, temperature, and the change in temperature. We want to explain that to whoever's reading our experiment write-up, and then we can pick any 2 columns. We could do time and temperature and look at the relationship between those columns. Or we could do temperature and change in temperature and look at the relationship between those numbers, okay? Same thing here. We want to give each table its own paragraph. And so for this paragraph, we want to make sure that we say, in this paragraph, we're focusing on change in temperature and the heat energy transfer every 5 minutes, right? And we're going to identify a trend that we see between these 2 columns, an important trend that would help someone gain insight into this lab and understanding into what the relationship is between these 2 quantities, okay? So after you finish that, you're ready for your conclusion. Your conclusion section is going to essentially be 3 sentences long. So first, you want to make sure that you state whether your hypothesis from the introduction was supported or not supported by the information you got from the lab. Once you do that, you next want to state which data table or what data specifically shows that your hypothesis was supported or was not supported. Once you identify that data, then you're going to take your third sentence to identify a real-world application for the information you learned from this lab. So if your hypothesis was supported, give a real-world explanation of an actual particular situation in which you see the principle that you talked about in your hypothesis at work. Or if your hypothesis was not supported, go ahead and give a real-world specific situation in which you see the principles that you see in your lab or that you found out in your lab at work, okay? All right, with that, you're ready to go ahead and do your lab experiment write-up. Thanks for watching. Have a great one.